This will be a series of programs for our flipped classroom lecture notes in which we are using the PowerPoint slides from the publisher Pearson that we use in our Math 106 college algebra class here at the University of Bridgeport. As part of this flipped classroom, you are to prepare by viewing and taking good notes on these lessons in your flipped classroom lecture notebook. Now, these will be part of your end of term grade and will be used for open notes quizzes. The objectives that we'll be going over, and you don't need to take notes on this part, plot points in the rectangular coordinate system, graph equations in the reticular coordinate system, interpret information about a graphing utilities viewing rectangular table, use a graph to determine intercepts, and intercept information given by a graph. Now, this gives you the general framework of what will be covered, and then you'll take notes on the specific examples and background. Now, in your notes, you're going to write the word background, and this will be background for what we'll be doing. So we want you to start by making a horizontal number line, like so, and then a vertical number line, like so. And what you've done is created the axes of a graph. Now, the vertical number line is the y-axis, and you should label that. The horizontal line is the x-axis, and label that. Now, since they're number lines, at this point is the ordered pair 0, 0, which is the origin. And going to the right here, these would be positive values. Going to the left, these would be negative values. And then moving up from this point, positive values below negative values. This also divides the graph into 4 quadrants that we can number 1. This will be the first quadrant. 2, and we use Roman numeral numbers for this, and you're writing this down. This is the second quadrant. This is the third quadrant, and Roman numeral 4 is a 1 slash before the V. This is 4. Now the ordered pair are x and y values in that particular order. So the x value here is 0, and the y value here is 0. An interesting thing, anything that's plotted in this area, they're both plus. Anything that's plotted in this would have a negative x value and a positive y value. In this third quadrant, they're both going to be negative. Now in the fourth quadrant, the x is positive, but the y is negative. Okay, so some basic background information on setting up a rectangular coordinate system here. Now in this slide, what we want you to do is just number these. You don't have to number too many, but you're going to create some slashes and set up something like this. This is just some additional information on the ordered pair that you may already have on your graph and the axes. And these will be critical as we do them. You're going to label this next part example 1. And you could put like a little box around it. So the statement is plot this point. So the ordered pair is a -2, 4. And the protocol for doing that is, again, this is an x value and a y value. Plot the x value first. So you start at the origin, you go over 2, and you can do this on your graph that you already have, and then up 4 and put a dot there. Now you could label that point 2 at this stage. And again, just a simple example. And this is in a sense part of the same one, but we can label it example 2. Plot this point now, 4, comma, -2. Well, again, you start at the origin, you go over to the right now since it's positive, and then you go down 2 and label this point, 4, comma, -2. Again, some easy stuff to start off with. This next slide goes over graphs of an equation, which background information I'd like you to write and put a star by this. And in graphing, we think of special forms of things. This one is called slope-intercept form. You may recall that. Y equals mx plus b, where m deals with the slope and b deals with what we'll call later the y-intercept, where the lines will cross the y-axis. Now, here is the general form that they're talking about. Y equals 4 minus x squared. If you write it in slope-intercept form, you put the x, the variable value first. And these, in a sense, are the same, just written slightly different. Now, notice there are two letters. There's an x value and there's a y value. So what we want is values for these letters that make the condition true. And these are graphs of equations. More on this as we go on. Now in example 3, we're looking for the graph of this. Notice it's in y equals mx plus b form, but they're also saying they want absolute values. So you're going to put values into this, but you will only want their positive results. Now they're setting up criteria that you want to start your values with a -4 for the x and a 2 as an ending value. We are on the next slide, and we're calling this example 4, but it ties in. And I'd like you to sketch what I am sketching here. So you're going to put a line here, a line there, a line there. Now you don't have to write all this out. Just do it with me and you're going to write this column and this column. So we said x values for this rule, which is y equals the absolute value of x plus 1. And then starting with a -4, going down to a 2, and you can pause while you write this. So if you put for the x value a -4, this becomes then the absolute value of -3, which is a +3, which gives us this ordered pair. Now, if you put a -3 in there, when you do this, and again, remember, absolute values are a grouping symbol. You do what's in there first. Get a -2, but then the absolute value of a -2 is 2. You get this. And then it actually follows a sequence. You don't have to write them all down. These, of course, are work them, but it just goes -3, -2, -1. And then these are the values that we get out of this. Now, in the next graph, we're going to ask you to actually do the graph of this. We're calling it example 5, but it all relates to item 3 here. So let's just sketch this. Again, a horizontal axis, a vertical axis, put some points here, and then again, pause and sketch this. You're plotting the values that you have in this T-chart above. And this is what that particular line looks like. And notice we only did a few of the points, and they would end here from a -4 to a 2. But if you went beyond that, that line would extend off in this direction and off in this direction. But for your graph, in a sense, you would only need to do the ones that we've plotted. This gives you the general sense of the graph. All right, let's go on. If you are fortunate to have a graphing calculator, then this would be something of interest where you set up the graphing utilities, go into the systems of your calculator and view the parameters for your viewing of the rectangle. Now, also, if you don't have a graphing calculator, there is this free graphing calculator site on the internet, desmos.com, that you can go. What I'm going to do up here is put this little circle with a lowercase letter I in it. If you click on that, that'll give you some more information on the free graphing calculator. All right, now I'd like you to write this word down, intercepts. We want to give you a definition of what intercepts are. Label this example 7. Now you're going to sketch a graph. Again, a vertical line, horizontal line. And here you can just sketch this one as a slash and this one as a slash. Well, we can do these others too. Now, what do you notice? Well, this is a line that is crossing the y-axis at this point. And the ordered pair of this point is 0, 5. And it's crossing the x-axis at this point, which is a -3, 0. When your x value is 0 and you have a y value, and we'll call that y value by the letter B. So your x value is 0 and it has a y value of B. This is called the y-intercept. The formal way of writing it, the standard form, is 0, B. And of course, these are ordered pairs that are in a parenthesis. So this is a specific one. Now, the general way of writing the ordered pair for the x-intercept is a, 0. And in the specific case, it's -3, 0. That's what the previous slide was going over. Here's an example, and there are the summaries of what we said. Now, for our last objective, and we're calling this example 8 here, write that down. The equation they're giving us is in slope-intercept form, changing the letters a little bit, D equals 4n plus 5. So this is something folks have worked out, which talk about the percentages of divorces if the wife is under 18 at the time of marriage. I'm not sure why they picked that particular example, but this is work that they've done and they've reported it. So determine the percentage of marriage ending in divorce after 15 years when the wife is under 18 at the time of marriage. Now, this is in a sociology class, so we're not going to go in there what are the causes of all these things. But again, moving on, we look at our next slide here. And if we put 15 where n is the number of years, we got 60 plus 5 is 65. So about 65% of marriages, again, this is just a statistic, and then going to the last slide, they want you to see if in fact this verifies what we've just said. So as we look at it, where is 15 on the graph? Well, 15 is right there. And then if you go up, where does that cross the line here? Right there. And if you go this way, you see there's where 65 is. So just a little sketch of this to support this. All right, this is our first lesson and one of many that we will be doing as part of our flipped classroom work.